The rate of diffusion of methane at a given temperature is twice that of molecular weight of X is. So RCH4 of methane is equal to 2R in grams of a gas. So mass of gas is equal to mass of molecular weight of methane into R, that is speed of methane and of gas square. So the rate of diffusion is twice, we know, so 16 into 2 square is equal to 64. So option A is the correct answer. 2 grams of hydrogen diffuses from a container in 10 minutes. How many grams of oxygen would diffuse through the same container in the same time under same or similar conditions? So we know that V0 upon VH volume is root of MH upon MO. We can write this as NO square upon NH square, that is number of moles, into mass. So number of moles can be mass upon molar mass is equal to molecular weight is 1 by 4. Therefore weight upon 32 is equal to 1 by 4. This comes out to be 8 grams. Option D is the correct answer. A gas diffuses at the rate which is twice that of another gas B. The ratio of molecular weight of A to B is. So molecular weight of A upon molecular weight of B is equal to rate of diffusion of B upon A the whole square. Since RA is equal to 2RB, so RB upon RA is equal to 1 by 2. Therefore 1 upon 2 square is equal to 1 upon 4, that is 0.25. Option D. If 4 grams of oxygen diffuses through a very narrow hole, how much of hydrogen would have been diffused under identical conditions? So we know that number of moles of oxygen and hydrogen is inversely proportional to the root of mass of hydrogen and oxygen. Substituting the values, solving this, we get 4 upon 32 into 2 upon the weight, which comes out to be 1 by 4. On solving this, the weight we get is 1 gram. Option B. A bottle of ammonia and a bottle of dry hydrogen chloride connected through a long tube are opened simultaneously at the both ends. The white ammonium chloride ring first formed will be at the center of the tube, B near hydrogen chloride bottle, C near ammonia bottle, D throughout the length of the tube. The ammonium chloride ring will be first formed near HCl bottle because the rate of diffusion of ammonia is more that of HCl, because ammonia, the masses of ammonia and HCl is 17:36.5. So ammonia will reach first to HCl bottle and will react there to form HCl, NH4Cl ring. So option B is the correct answer. The density of two gases are in the ratio 1:16. The ratio of the rate of diffusion is. So the density d1 upon d2 is equal to 1 by 16 from the given question. The rate of diffusion is r1 upon r2 is equal to root of d2 upon d1. This is a relation inversely proportional to the square root. Root of 16 is equal to 4. So option B is the correct answer. Molecular weight of a gas that diffuses twice as rapid as the gas with molecular weight of 64 is. One gas has weight 64, rate of diffusion is R2 is 2R1. So we have to find M2 is equal to M1 R1 upon R2 the whole square. So 64 into 1 upon 4, which comes out to be 16. So option A is the correct answer. A gas diffuses 1 by 5 times as fast as hydrogen, its molecular weight is. So we know that gas diffuses 1 by 5 times of hydrogen. So mass of gas upon mass of hydrogen is equal to rate of diffusion of hydrogen and gas the whole square. So phi the whole square is equal to 25. So mass of gas is equal to 2 into 25, which is 50. Option A. The ratio of rate of diffusion of gas given element to that of helium is 1:4. The molecular weight of the element is. So we know that rate of diffusion of gas and that of helium is inversely proportional to the square root of mass of helium and mass of gas. So mass of gas is equal to mass of helium into r square of helium and r square of gas. Substituting the values, we get 4 upon 1.4 the whole square. On solving this, we get 2. So option A is the correct answer. Which of the following gas will have highest rate of diffusion? The molecular weight of ammonia is 17 and that of nitrogen 28. Carbon dioxide is 44 and oxygen is 32. So the rate of diffusion is inversely proportional to the square of molecular weight. So option A, ammonia, as it has least molecular weight, so that it has highest rate of diffusion. Equal amount of two gases of molecular weight 4 and 40 are mixed. The pressure of mixture is 1.1 atmosphere. The partial pressure of light gas in this mixture is. So number of moles of lighter gas is m by 4. The number of moles of heavier gas is m by 40. So total number of moles is equal to m by 4 plus m by 40, which comes out to be 11 m by 40. So the mole fraction of the lighter gas comes out to be m by 4 divided by 11 m by 40, which is 10 by 11. The partial pressure of the lighter gas is equal to original pressure into mole fraction of the lighter gas. So 1.1 into 10 by 11. So option C is the correct answer. A sample of gas occupies 100 ml at 27 degree and 740 mm pressure. When its volume is changed to 80 ml at 740 mm pressure, the temperature of the gas will be. We know that P1 V1 upon T1 is equal to P2 V2 upon T2. Therefore, T2 is equal to P2 V2 upon P1 V1 into T1 by rearranging. So the pressure is same 740, volume is 80 by 100 into 300. So the temperature comes out to be 240 Kelvin, which is minus 33 degrees Celsius. Option C is the correct answer. The density of gas at 27 degrees Celsius and 1 atmosphere pressure is D. Pressure remaining constant, at which of the following temperature will the density become 0.75 D? So we know that in the following question, vol is directly proportional to number of moles into temperature, which is directly proportional to mass upon molar mass into temperature. So V1 upon V2 is equal to M1 upon M2 into T1 upon T2. Therefore, T1 upon T2 is equal to V1 upon M1 into M2 upon V2. Therefore, density D2 upon D1, which is mass upon volume, is 300 Kelvin upon T2, which is 0.75 D upon D. Therefore, T2 is equal to 350 upon 0.75 D, which is 400 Kelvin. So option C is the correct answer. A weather balloon filled with hydrogen at 1 atmosphere and 27 degree has volume equal to 12,000 liters. On ascending, it reaches a place where the temperature is minus 23 degrees Celsius and pressure is 0.5 atmosphere. So the volume of balloon is. So we know that V2, that is volume, is equal to P1 T2 P2 T1 into V1. So volume is directly proportional to temperature, inversely proportional to pressure. So substituting the values into 12,000 liters, so this comes out to be 20,000 liters of volume. So option D is the correct answer. 1 liter of gas weight 2 gram at 300 Kelvin and 1 atmosphere pressure. If the pressure is made 0.75 atmosphere, at which of the following temperature will 1 liter of the same gas will weigh 1 gram? We know that P1 V1 upon N1 T1 is equal to P2 V2 upon N2 T2. Therefore, T2 is equal to P2 V2 T1 P1 V1, and for number of moles we can write it as M1 upon M2. So substituting the values 0.75 upon 1 into 1 upon 1, which is volume, to 2 upon 1, and the temperature is 300 Kelvin, so this comes out to be 450 Kelvin. So option A is the correct answer. At NTP, the volume of gas is found to be 273 ml. What will be the volume of gas at 600 mm of Hg at 273 degrees Celsius? So when you know that PV is equal to nRT, from this equation we can write this V2 is equal to P1 V1 T2 upon T1 P2, as the number of moles and R are constant. So 760 upon 600 is the pressure, 546 upon 273 is the temperature into 273. So this comes out to be 691.6 ml of volume. So option C is the correct answer. Pure hydrogen sulfide is stored in a tank of 100 liter capacity at 20 degrees Celsius and 2 atmosphere. The mass of the gas will be. So we know that N is equal to PV upon RT. N we can write as mass upon molecular mass. Therefore mass is equal to MPV upon RT. Now we have to substitute the values. 34 is the mass of hydrogen sulfide to 2 into 100 gas constant into 293 Kelvin. So this comes out to be 282.4 grams. So option C is the correct answer. 16 gram of oxygen and 3 gram of hydrogen are kept at 760 mm pressure and 0 degree. The total volume occupied by the mixture will be nearly. So number of moles of oxygen is 16 by 32, which comes out to be half. Similarly, number of moles of hydrogen is 3 by 2. Total number of moles is 3 by 2 plus 1 by 2, which comes out to be 2. So volume is equal to nRT upon P. So total number of moles is 2, gas constant, temperature divided by pressure. So this comes out to be 44.8 liters or 44800 ml. So option D is the correct answer. Two separate bulb contains ideal gas A and B. The density of gas A is twice that of gas B. The molecular mass of A is half that of B. The two gases are at same temperature. The ratio of pressure of A to B is. So density of A is equal to twice of density of B. So mass of 2 Ma is equal to mass of B. So we know that PV is equal to nRT. So P is equal to M upon capital M RT upon V. So mass and volume, which we can write as density. Therefore P is equal to dRT upon M. For ratio, substituting the values, PA upon PB is equal to dA MB dB MA. So 2 upon 1 into 2 upon 1, which comes out to be 4:1. So option C is the correct answer. At 0 degree and 1 atmosphere pressure of a gas occupies 100 cc. If the pressure is increased to 1.5 liter, the temperature is increased by 1/3 of absolute temperature, then the final volume of the gas will be. So we know that volume V2 is equal to P1 V1 T2 upon P2 T1, but P1 is equal to P and T1 is equal to 273 kelvins, and T2 is equal to 3 by 2 of P, and T2 can be write as T1 plus T1 by 3, which is 4 by 3 into 273 Kelvin. So volume V2 is equal to 2P upon 3P. 4 by 3 into 273 is the temperature into 100 cc. So this on solving comes out to be 88.88 cc. So 88.9. Option B is the correct answer. Volume of 0.5 mole of gas at 1 atmosphere pressure is 273 Kelvin is. So we know that volume is equal to nRT upon P. Substituting the values, R is universal gas constant, temperature in kelvins, and 1 is the pressure. So this comes out to be 11.2 liters. So option B is the correct answer. If 2 moles of an ideal gas at 546 Kelvin occupy a volume of 44.8 liter, the pressure must be. So pressure is equal to nRT upon V. Number of moles is 2 into 0.082 is the universal gas constant, 546 is the temperature, 44.8 liters is the volume. So pressure comes out to be 2 atmosphere on solving the above equation. So option A is the correct answer. Compressibility of gas is less than unity at STP. Therefore, so compressibility is equal to PV upon nRT, which is less than 1 at STP, which is given. From this we can interpret that nRT is greater than PV. N into 0.0821 into 273 is greater than 1 volume. So 22.4 liters is greater than Vm. So option B is the correct answer. A gas mixture contains oxygen and nitrogen in the ratio 1:4 by weight. The ratio of the number of the molecules is. So the ratio of oxygen and nitrogen by weight is 1:4. So the ratio of oxygen and nitrogen by moles is 1 by 32 is to 4 by 28, which comes out to be 7:32. So option D is the correct answer. A certain sample of gas has a volume of 0.2 liters measured at 1 atmosphere pressure and 0 degree. If the same pressure but at 273 degrees Celsius, its volume will be. So we know that V1 upon V2 is equal to T1 upon T2. Since V2 is equal to T2 V1 upon T1, substituting the values 546 upon 273 into 0.2 liters. On solving this we get 0.4 liter as the volume V2. So option A is the correct answer. Pressure remaining the same, the volume of a given mass of ideal gas increases for every degree centigrade rise in temperature by definite fraction of volume at. So we know that Vt is equal to V0 1 plus alpha T. Since V2 minus V1 is delta V, if T2 minus T1 is equal to 1 degree, then delta V is equal to alpha V0 from this. For every 1 degree rise in temperature, the volume of a given mass of ideal gas increases by a definite fraction of 1 by 273.15 of V0. Here V0 is volume at 0 degree temperature. So option A is the correct answer. Gaseous mixture contains 56 gram of nitrogen, 44 of carbon dioxide, 16 of methane. The total pressure of mixture is 720 mm of Hg. The partial pressure of methane is. So first of all, we have to calculate the number of moles. So number of moles of nitrogen is equal to 56 by 28, which is 2. For CO2, it is 44 by 44, which is 1. And for methane is 16 by 16, which is also 1. So total number of moles is equal to 2 plus 1 plus 1, which is 4. Mole fraction of methane is 1 by 4. Therefore, partial pressure of methane is mole fraction into total pressure. So 1 by 4 into 720, which comes out to be 180 atmosphere. So option C is the correct answer. Density of two gases are in the ratio 1:2 and the temperature in the ratio 2:1. Then the respective pressure is. So we know that D1 upon D2 is equal to half. T1 upon T2 is 2 upon 1. Therefore, P1 upon P2 is equal to V2 into T1, V1 into T2. So we can write this as T1 upon T2 is equal to D1 upon D2. Therefore, P1 upon P2 is 2 into 1 upon 1 into 2, which is 1 upon 1. So option A is the correct answer. If 20 centimeter cube of gas at 1 atmosphere is expanded to 50 centimeter cube at constant temperature, then what is the final pressure? At constant temperature, P1 V1 is equal to P2 V2. So 1 into 20 is equal to P2 into 50. Therefore, P2 is equal to 20 upon 50 into 1. So option E is the correct answer. The ratio of specific charge of proton and alpha particle is. Charge of proton is +1 and charge of alpha particle is +2. So the ratio will be 2:1. Option A.